Praise the Lord. Hi, hello and welcome back. You are watching Namma Gurugulu YouTube channel. Dear students, this is a short video on physics where we will be doing a very small derivation. This derivation, to solve it, you need just 5 minutes. Okay, it's a very small derivation which will be asked for 5 marks. Okay, I think you are excited to know which derivation it is. I'm not going to keep you much time in guessing. Let's directly go on to this. So though the derivation requires 5 minutes to be solved, I want you to go through the basics before solving the derivation. Okay, so hence it may take somewhere around 15 to 20 minutes, or it may take less than that. Okay, so let's directly go on to the question. What is the derivation all about? Okay, yeah, right, on your mark, get set, let's go. So the question or the derivation which you're going to see today is derive the condition for balance of a Wheatstone network using Kirkhofs laws. Okay, I know many students, you know this. If only you have any doubts, it will be cleared in this video. Okay, I repeat the question once again. Derive the condition for balance of a Wheatstone network using Kirkhofs laws is what you have heard till now. Actually, now Indians ಹೇಳುವಾಗ ಇದನ್ನ Kirchhoff's laws ಅಂತ ಹೇಳ್ತೀವಿ. But actually, foreign accent ಅಲ್ಲಿ ಇದು ಕೇಳೋದಾದ್ರೆ, this actually name sounds Kirkhofs ಅಂತ. ಕೇಳಿಸ್ತಿದೆಯಾ? ನಾವು Kirchhoffs ಅಂತೀವಿ. Actually, R will be silent here. This actually in English foreign pronunciation ಅಲ್ಲಿ ನೋಡೋದಾದ್ರೆ using Kirkhofs law ಅಂತ ಹೇಳುತ್ತೆ. Okay, whatever it is. ಹೆಸರು ಕಟ್ಕೊಂಡು ನಮ್ಗೆ ಏನಿದೆಯಪ್ಪ, directly go for the derivation. So ಈಗ before you go into the basic of the derivation, okay, you should know what is a Wheatstone network and you should know something about Kirchhoffs laws. Okay, what does the Kirchhoffs law state? If you know the statements of the Kirchhoffs law, or as I told you, Kirchhoffs law, and you know what is a Wheatstone network, then you should go for the condition for the balanced of the Wheatstone network. Okay, yeah. So as soon as you say a Wheatstone network, you will come across this junction or this picture, isn't it? So I'm going to explain this picture in quite a bit detail, and then we shall go on to the derivation part. Okay, this question is one of the important question, and if this question is asked for the examination, I believe you will definitely get 5 marks. It will be in your pocket because it is as easy as this. Okay. ಜನ ಸುಮ್ಮನೆ ಹೇಳ್ತಾರಲ್ವಾ, ಕಬ್ಬಿನ ಜಲ್ಲೆ ತಿನ್ನೋಕ್ಕೆ ಕಾಸು ಕೊಡಬೇಕಾ ಅಂತ. ಸೊ you will easily get 5 marks if this question is given. Okay, yeah, let's go to the basics of the question. So what is a Wheatstone bridge or Wheatstone network ಅಂತ ಕರೀತಾರೆ, Wheatstone bridge ಅಂತ ಕರೀತಾರೆ, everything is same. So a Wheatstone bridge is an electrical circuit. ಏನು ಸರ್ಕ್ಯೂಟ್ ಇದು? Remember, it is an electrical circuit. Okay, so why do we need this? So ಒಂದು ಹಂಗಂದ್ರೆ ಏನು? ನೆಕ್ಸ್ಟು, why do we need this? It is used to measure an unknown electrical resistance by balancing 2 legs of a bridge circuit. ಓಕೆ, ಸೊ ಏನಿದು Wheatstone ನೆಟ್ವರ್ಕು ಎಲೆಕ್ಟ್ರಿಕಲ್ ಸರ್ಕ್ಯೂಟು ಏನು ಮಾಡುತ್ತೆ? ಇಟ್ ಈಸ್ ಯೂಸ್ ಟು ಮೆಷರ್ ಆ್ಯನ್ ಅನ್ನೋನ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಹೇಗೆ ಮೆಷರ್ ಮಾಡುತ್ತೆ? ಬೈ ಬ್ಯಾಲೆನ್ಸಿಂಗ್ 2 legs ಆಫ್ ಎ ಬ್ರಿಡ್ಜ್ ಸರ್ಕ್ಯೂಟ್, one leg of which includes unknown component. 2 legs of the bridge circuit ಇರುತ್ತೆ, ಅದರಲ್ಲಿ ಒಂದು unknown component ಇರುತ್ತೆ. ಓಕೆ, ಇಟ್ಸ್ ಆ್ಯಸ್ ಸಿಂಪಲ್ ಆಸ್ ದಿಸ್. ಅರ್ಥವಾಗ್ತಿದೆಯಲ್ಲ? ಒಂದು ನೆನ್ಪಿಟ್ಕೋಬೇಕು, Wheatstone bridge ಅಂದ ತಕ್ಷಣ ಇಟ್ ಈಸ್ ಅನ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಸರ್ಕ್ಯೂಟ್. ಆಯಿತಾ? ನೆಕ್ಸ್ಟು ಏನಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀರಿ? ಟು ಮೆಷರ್ ಎನ್ ಅನ್ನೋನ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಓಕೆ, ಹೇಗೆ ಮೆಷರ್ ಮಾಡೋದು? ಬೈ ಬ್ಯಾಲೆನ್ಸಿಂಗ್ 2 legs ಆಫ್ ಎ ಬ್ರಿಡ್ಜ್ ಸರ್ಕ್ಯೂಟ್. ಅರ್ಥವಾಗ್ತಿದೆಯಾ? ಸೊ ಈ 2 legs ಹೇಗಿರುತ್ತೆ? 1 ಲೆಗಲ್ಲಿ 1 leg ಆಫ್ ವಿಚ್ ಇನ್ಕ್ಲೂಡ್ಸ್ ದಿ ಅನ್ನೋನ್ ಕಾಂಪೊನೆಂಟ್. ಇಸ್ ಇಟ್ ಕ್ಲಿಯರ್? ತುಂಬ ಸಿಂಪಲ್ ಅಷ್ಟೇ Wheatstone ಬ್ರಿಡ್ಜ್ ಅಂದರೆ. ನಾವು ದಿಸ್ ವಾಸ್ ಇನ್ವೆಂಟೆಡ್ ಬೈ ಸ್ಯಾಮ್ಯುಯಲ್ ಹಂಟರ್ ಕ್ರಿಸ್ಟಿ ಇನ್ 1833. ಇದು ಸುಮ್ಮನೆ ಒಂದು ಇನ್ಫಾರ್ಮೇಷನ್ಗೋಸ್ಕರ ಅಷ್ಟೇ, ನಾಟ್ ನೀಡೆಡ್ ಫಾರ್ ಎಕ್ಸಾಮಿನೇಷನ್. ಓಕೆ ಸರ್, ಸ್ಯಾಮ್ಯುಯಲ್ ಹಂಟರ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ರು ಅಂತೀರಿ, ಇದು Wheatstone ಅಂತ ಹೇಳ್ತೀರಲ್ಲ ಅಂತ. ಡೋಂಟ್ ವರಿ. ಸೊ ದೋ ಇಟ್ ವಾಸ್ ಇನ್ವೆಂಟೆಡ್ ಬೈ ಸ್ಯಾಮ್ಯುಯಲ್ ಹಂಟರ್, ಇಟ್ ವಾಸ್ ಇಂಪ್ರೂವ್ಡ್ ಆ್ಯಂಡ್ ಪಾಪ್ಯುಲರೈಸ್ಡ್ ಬೈ ಸರ್ ಚಾರ್ಲ್ಸ್ Wheatstone. ಗೊತ್ತಾಗ್ತಿದೆಯಾ? ಸೊ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ದು ಇವರೇ, ಬಟ್ ಇದನ್ನು ಪ್ರಸಿದ್ಧಿ ಮಾಡಿದ್ದು ದ ಒನ್ ಹೂ ಪಾಪ್ಯುಲರೈಸ್ಡ್ Wheatstone bridges, Sir Charles Wheatstone. That is why this bridge he has taken his own name. ನಾವು ಸಾಮಾನ್ಯವಾಗಿ ಏನನ್ನು ಯಾವುದಾದ್ರೂ ಸೈಂಟಿಫಿಕ್ ಇನ್ವೆನ್ಷನ್ ಆದರೆ ದೇ ಕೀಪ್ ದ ಇನ್ವೆಂಟರ್ಸ್ ನೇಮ್. ಸೊ ಇಟ್ ಈಸ್ ಆಲ್ಸೋ ಸೇಮ್ ಸ್ಟೋರಿ ಹಿಯರ್. It was invented by Sir Charles Wheatstone in 1843. Okay, so how does the Wheatstone Bridge look like? So Wheatstone Bridge, it will look like this. You will have a resistance, 4 resistors, R1, R2, R3, and this is the unknown resistance. Okay, unknown component annala Rx anta. We know this is the galvanometer. Okay, so this is the 2 legs. Erad leg irutte illi. Current is passing. Okay, when current is passing through the circuit, there is a voltage supply here. Current along R1 will be I1. Current along R2, R3 will be I3. Current along R2, that is second resistor, will be I2, and along Rx will be Ix. Simple. ಯಾವ resistor ಇದೋ ಅದರ corresponding current flow ಆಗುತ್ತೆ. And this is very important component. This is the galvanometer connected. Is it clear? ಈ ಬ್ರಿಡ್ಜಲ್ಲಿ ಒಂದು galvanometer connect ಆಗಿರುತ್ತೆ. There will be current flowing along the galvanometer is denoted by Ig. Is it clear? What is Ig? I suffix G means I indicates current, G indicates galvanometer ಅಷ್ಟೇ. ದೊಡ್ಡ ಸೀಕ್ರೆಟ್ ಏನಿಲ್ಲ. Ig means current flowing across the galvanometer. Is it clear? ಗೊತ್ತಾಗ್ತಿದೆಯಲ್ಲ? ಇಷ್ಟು ಸಿಂಪಲ್. ಸೊ Wheatstone Bridge ಅಂದರೆ ಇಷ್ಟೇ ಇರೋದು. ಈಗ ಇದರ ನೆಕ್ಸ್ಟು Kirkhofs Law. Let's see what is all about the Kirkhofs Law, or according to your pronunciation, Kirchhoff's laws. Before going to the Kirkhofs Law, please note down this point. Very important point. Twice it has been asked in your examination for 1 mark. What is the condition for the Wheatstone network to be balanced? This is the condition. Ig is equal to 0. Answer Ig 0 means the Wheatstone bridge is balanced when there is no current through the galvanometer. So when the current does not pass through the galvanometer, then we say the Wheatstone network is balanced. So the other way of saying it means potential at B is equal to potential to that at D. Andre there will be 2 junctions here. The potential at the point B will be same as the potential at the point D, because there will be no current passing through the galvanometer. Is it clear? So we say there is no current passing through the galvanometer, or the current through the galvanometer is 0 ಅಂತ ಹೇಳ್ತೀವಿ. Both are same. So what is the main condition for the Wheatstone network or Wheatstone bridge to be balanced? Please note it down. Ig, that is current along the galvanometer, is 0. Is it clear? ಅರ್ಥ ಆಗ್ತಿದೆಯಲ್ಲ? And note down this point also. That means potential at B is same as potential at D. ಅರ್ಥ ಆಗ್ತಿದೆಯಲ್ಲ? Okay. Now let's go to the Kirchhoffs laws. In Kirchhoffs laws, there are 2 laws. One is KCL, which is Kirchhoffs current law. The other one is KVL, which is Kirchhoffs voltage law. Okay. So what does KCL says that? KCL ಏನು ಹೇಳುತ್ತೆ? Very simple ಇದು. The algebraic sum of all the currents entering and existing a node is equal to 0. ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, please note this down, because we will use this in the derivation. So what does KCL states? Karnataka Cricket League ಅಲ್ಲ, Kirchhoffs current law. Okay, so it states that the algebraic sum of all currents entering and existing. So the algebraic sum of all currents entering and exiting. Exiting ಅಂದರೆ ಏನು? ಲೀವಿಂಗ್, ಆಚೆ ಹೋಗೋದು. ಎಂಟಿಂಗ್ ಅಂದರೆ ಒಳಗೆ ಬರುವಂಥದ್ದು ಮತ್ತು ಹೊರಗೆ ಹೋಗುವಂಥದ್ದು. ಸೊ algebraic sum of all currents entering and exiting a node is equal to 0. So how to remember? Very simple. KCL means sigma I is equal to 0. Sigma means the summation of all the currents is equal to 0. Some textbook they take small I, but generally we consider capital I, because current we consider it as capital I. So sum of all the currents entering and exiting a node, we take it as 0. This is what KCL states. Okay. Next we have, what is the meaning of this? The total current entering a junction is equal to the total current leaving the junction. Are you following? The total current entering a junction is equal to the total current leaving the junction. This is also called the Kirchhoffs junction rule anta kariತೀವಿ. Okay. To confuse sometimes for 1 mark, they may ask you, define Kirchhoffs junction rule. So junction rule means it is the KCL, which is the current rule. Is it clear? This is the meaning of the KCL. Okay. Now we shall go on to KVL. So the KVL, which is Kirchhoff's voltage law, states that the algebraic sum of the potential differences, that in the Kirchhoff's current law is depending upon current and Kirchhoff's voltage law is depending upon the voltage. Okay, so the algebraic sum of the potential differences in any loop must be equal to 0. There it was summation I equal to 0. Here it is summation V is equal to 0. What is V? Potential difference or the voltage. Is it clear? Are you following? The algebraic sum of the potential differences in any loop must be equal to 0. Okay. What is the other way of saying this? Adwa idna kelu textbooks alli ee ತರ ಕೂಡ ಹೇಳ್ತಾರೆ. In a closed loop, ನೆನಪಿಟ್ಕೊಳ್ಳಿ, ಅಲ್ಲಿ ನೋಡ್ ಇರುತ್ತೆ, ಇಲ್ಲಿ ಲೂಪ್ ಇರುತ್ತೆ. Difference between KCL and KVL. In KCL we consider a node, in KVL we consider a loop. Is it clear? So in a closed loop, the algebraic sum of the EMFs, electromotive force, electromotive force. So in a closed loop, the algebraic sum of the EMFs is equal to the algebraic sum of the product of resistance and the respective current in them. Okay, actually it is denoted by summation of E. What is summation of E? That is the algebraic sum of the EMFs. Okay, that is equal to the algebraic sum. So it is very easy to remember in this way. Either you can remember this summation V is equal to 0, or in some cases we take summation E is equal to IR. We know that is the product of I into R means that is the product of R is the resistance and I is the respective current. Okay, is it clear? Yeah, and we know V is equal to IR. We also know that. So please remember this Kirchhoff's voltage law. And one more note, and because this Kirchhoff's voltage law is with respect to loop, this is also called Kirchhoff's loop rule. Okay, loop law or loop rule. Is it clear? So this is the required basics we require to prove the Wheatstone network balancing concept. Now we shall go to the derivation. Hope you are ready for this. Right, so I've taken the Wheatstone network. I've taken resistances P, Q, R and S. A current along P would be I1. Current along Q would be I3. Because current along R I'm taking it as I2. So current along S is I4. This is a galvanometer and current along it is IG. And current passing through it. Okay, and this is a voltage supply. Okay, now please note down how I'm going to start. Note it down. Let I1, I2, I3 and I4 and IG. There are 5 current things. I1, I2, I3, I4, IG are the current through the resistances. Please make sure how you write in order. For I1, you write P. For I2, it's not Q, it is R. So it is I1, I2, I3, I4 and IG be the current through the resistances P, R, Q, S and G. What is G? Galvanometer, respectively, as shown in the figure. So I've just writing down what I have shown in the figure. Is it clear? So ನಮಗೆ ಈ ಡೆರಿವೇಷನ್ ಡಿರೈವ್ ಮಾಡೋಕ್ಕೆ ಬೇಕಾಗಿರುವಂಥ ಥಿಯರಿ ಅಂದರೆ ಜಾತಕ ಇಷ್ಟೇ. Okay, now we will directly go on using the Kirchhoffs laws. And one more thing, dear students, kindly note down the direction of the currents, because current is a vector, direction matters. Okay, so how we start the derivation? We start by applying. So first step is, remember, applying what? KCL, that is Kirchhoff's current law, where elige to junction B. First we will apply KCL to junction B. Okay, what happens if we apply KCL to junction B? So what does KCL says? Sigma E is equal to 0. Now the current flowing into B. So current flowing into B is actually I1. So whatever the current flows into will be positive. Whatever going out is negative. Okay, so it is I1. IG is going outside. So I1 minus IG. I3 is also going outside. Minus I3. This is nothing but 0. Let me take it as equation 1. Okay, I applied KCL to junction B. I get the sum of, we know sum of current entering and exiting will be equal to 0. So I1 minus IG minus I3, that is equal to 0. Okay, now I will apply KCL in the same way to junction D. So applying KCL to junction D, what is the current? I2 is actually entering the junction, so it is I2. Current along the galvanometer is also entering, so it is IG, and but I4 is going out. Minus I4 is equal to 0. So this will give my equation 2. Okay, first I applied KCL to junction B. Next I applied KCL to junction D. Okay, now I will apply KVL, that is Kirchhoffs voltage laws. Okay, now look here. We shall apply Kirchhoffs voltage law to closed loop ABDA. ABD and Takshana Abram de Villiers Nenpaguito RCB. Okay, forget about it. So if we apply Kirchhoffs voltage law to the closed loop ABDA, okay, so we know that sigma V is equal to 0. Sigma V, and then we know V is equal to I into R. Okay, here V is nothing but I. What is the current? So it is I1, and resistance is nothing but P. Okay, so you look here. So it is I1 into P, okay, plus Ig, that is current along the galvanometer, into G, galvanometer, because this is following the same direction. Because it is in the opposite direction, so this will be minus I2 into R. So this will be equal to 0. Why? KVL says that sigma V is equal to 0. Let me take it as equation 3. In the same way, let me apply KVL to the closed loop CBDC. So let us apply KVL to the closed loop BCDB. Okay, so the current, let's see, let's take I3 into Q, which is V, and here it is in the opposite direction. Okay, so it is, or you can take first Ig plus Ig into, sorry students, it's minus, because once it starts flowing this direction, it is I3 into Q. Now this is in opposite direction, which is minus, you can take I4 into, yes, again if you take this loop, it is again minus, because its direction is opposite. Ig into what is the resistance here? Resistance is galvanometer. This is nothing but 0. So I get equation 4. Okay, so once these 4 equations are ready, let me use the condition of the balanced Wheatstone network. Okay, so the Wheatstone network is balanced when, what is the condition? When Ig is equal to 0. Okay, so if we can take this equation as star, because this is the main equation. Okay, now I don't want the derivation. Let us take the equations. Okay, so because Ig is equal to 0, from equation 1, what happens to equation 1? Ig is equal to 0. So we get I1 is equal to I3. Okay, from equation 1 we get I1 is equal to I3 because Ig is equal to 0. Similarly, from equation 2 we get I2 is equal to I4 once again because Ig is equal to 0. It's quite easily understandable. Is it clear? ಇದರಲ್ಲಿ ದೊಡ್ಡ ತೊಂದರೆ ಏನಿಲ್ಲ. Ig 0 ಆಗೋದ್ರಿಂದ ಇದನ್ನ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ತಗೊಳ್ತಾ ಇದ್ದೀನಿ. I1 is equal to I3 ಸಿಗುತ್ತೆ, ಮತ್ತೆ ಇಲ್ಲಿ I2 is equal to I4 ಅಂತ ಸಿಗುತ್ತೆ. Okay, in the same way, now let me consider here, if I take equation 3, so let me take it in a group. Okay, so if I consider equation 3, here again Ig becomes 0, so I'll get I1p is equal to I2r. That is I1p is equal to I2 into R. Is it clear? Okay, now similarly from equation 4 we get, again since Ig G is equal to 0, we'll get I3q is equal to I4s. Artha aita? Because I'm taking it to the right hand side. I'm directly writing this. Once this is clear, we don't have to worry much. Now let me take this equation as 5 and let us take this as equation 3. So see what I'm going to do. Very important step. So if you take equation 5 divided by equation 6, what I'll get? We get, okay, I1p divided by I3q is nothing but I2r divided by I4s. Is it clear? So left hand side I am dividing I1p divided by I3q. is equal to I2R divided by I4S. Okay, so you can now this is nothing but, therefore you can take I1P divided by, I can replace I3 is equal to I2 ಇರೋದ್ರಿಂದ I3 ನ ನಾನು I1 ಅಂತ ಬರಿತೀನಿ. So this becomes I1Q. Similarly I2 ಅದೇ ಹಾಗೆ ಇಟ್ಕೊಬಿಡಿ. Now because I4 is equal to I2, any one you can change. I4 ಬದಲು I2 ಅಂತ ಬರೀಬೋದು, ಅಥವಾ I2ನ I4 ಅಂತ ಬರೀಬೋದು, ಯಾವುದಾದ್ರೂ ಒಂದು. Now I1 gets cancels, I2 gets cancels, therefore you will get the final equation P divided by Q is equal to R divided by S. This is my required condition for balanced Wheatstone network. So once the equation is ready, please frame it down. Ekandre idu presentation skill torsute. It looks very nice. Okay. Hence the required result. You can say hence the required result. ಬರೀಲಿಲ್ಲ ಅಂದರೂ ಪರವಾಗಿಲ್ಲ, ಇದನ್ನು ತೋರಿಸಿದ್ರೆ ನಮಗೆ ಸಾಕು. ದಿಸ್ ಇಸ್ ದ ಕಂಡೀಷನ್ ಫಾರ್ ದ Wheatstone ನೆಟ್ವರ್ಕ್ ಟು ಬಿ ಬ್ಯಾಲೆನ್ಸ್. ಓಕೆ, ಸುಲಭ ಅಲ್ಲ, ತುಂಬ ಈಸಿ ಅಲ್ವಾ? ಸೊ ನಾನು ಹೇಳ್ಕೊಡೋಕ್ಕೆ ನಿಮಗೆ ಡೆರಿವೇಷನ್ 7ರಿಂದ 8 ನಿಮಿಷ ತಗೊಂಡಿರ್ಬೋದು, ಬಟ್ ನೀವೇ ಒಂದು ಸರಿ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡೋಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ರೆ ಇಟ್ ಟೇಕ್ಸ್ ಲೆಸ್ ದೆನ್ 5 minutes. ಸೊ ಎಕ್ಸಾಮಲ್ಲಿ ಕೊಟ್ಟರೆ 5 ನಿಮಿಷಕ್ಕಿಂತ ಕಡಿಮೆಯಲ್ಲಿ 5 ಮಾರ್ಕ್ಸ್ ತಗೋಬೋದು. ಇದು ತುಂಬ ಸುಲಭವಾದ ಡೆರಿವೇಷನ್. ನೀವು ಇದನ್ನು ಡಿರೈವ್ ಮಾಡೋದಕ್ಕೆ ನೀವೇನು ಆಲ್ಬರ್ಟ್ ಐನ್ಸ್ಟೀನ್ ಅಷ್ಟು ಇಂಟೆಲಿಜೆಂಟ್ ಆಗೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಕಾಮನ್ ಸೆನ್ಸ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಸಾಕು. ಓಕೆ, ಒನ್ ಥಿಂಗ್ ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್, ವಾಟ್ ಈಸ್ Wheatstone ನೆಟ್ವರ್ಕ್. ನೆಕ್ಸ್ಟ್, ದ Kirkhofs laws, which is KCL and KVL. If you know that, once you apply KCL to 2 junctions, next you apply KVL to 2 loops. Equations will be ready. Use the condition for the Wheatstone network. Everything will be balanced. Is it clear? ಇಷ್ಟ ಆಯ್ತಾ? ಅರ್ಥ ಆಗಿದೆಯಲ್ಲ? Okay, fine. Right students, we have almost come to the conclusion of this session. I hope you have enjoyed this video. Before me saying this, ನಾವು ಹೇಳೋದಕ್ಕಿಂತ ಮುಂಚೆನೇ ನೀವು ವಿಡಿಯೋ ಲೈಕ್ ಮಾಡಿದ್ದೀರ ಅಂತ ಅನಿಸುತ್ತೆ. You have already clicked the like button, which shows your support for us. Okay, so thanks for watching the video. You can expect a few more videos coming from this channel, particularly for your benefits. Okay, so kindly, my one request is share the video with your friends so that it may be useful even for them. Okay students, take care of yourself. Thanks for you watching the video. We'll meet again in the next session. Until then, take care and bye.